My name's Scott Brown, and this is a pre-recorded presentation for the 2022 annual meeting of the Society for MathPsych in Toronto. This is particularly a presentation for the symposium in honour of Tony Marley. Tony had a huge role in my life as an academic. He was a great friend and mentor, and he also kick-started a long-standing and now quite strong research strength in the School of Psychology at the University of Newcastle that's about how people elicit preferences. I had tried to travel to Toronto to present this in person, but COVID things got in the way and I can't be there. So this is about eliciting preferences, and in particular about a discrete choice experiment, which is one way to elicit preferences. So here's a simple example. On the left-hand side of the screen is a discrete choice. There's two kinds of nuclear plants that you might want to choose, Project A and Project B. They differ in lots of attributes, how far you are from the nuclear plant, emissions reduction, and so on. A discrete choice experiment is a way of working out how people feel about those attributes, how much they care about distance from the nuclear plant, and so on. And the way it works is you ask lots of choices like this that differ in the attribute levels. And with some fancy analyses, which actually Tony pioneered in many cases, you can work out very accurately how people feel about those things. In the lab here at Newcastle, we've made lots of use of the discrete choice experiment. We've used it in applied and basic research. In applied settings, we've used it with end user partners about healthcare choices, chemotherapy and things like that. Also local public transport options, consumer choices, community support policies, many things. But of course, it's not the only way to get at people's preferences. Another way to get at people's preferences is to use a rating scale, a Likert scale, for example. Here's something corresponding to the nuclear project example, but with Likert scales. All you do is list each attribute one at a time, like distance from the nuclear plant, and you ask, how important is this one to you? And people rate it from not at all up to very important, 1 to 7, things like that. Now, the DCE has many advantages. Here's a list of some of Tony's most cited papers, and you'll notice they're often about DCEs and best worst scalings, which are a certain type of DCE. And the reason these are some of his most cited papers is because using a DCE has huge advantages in working out people's preferences. Particularly, you can get at quantitative trade-offs between how people value changes in one attribute versus changes in the other. How much emissions reduction are they willing to give up to live further from the power plant, that kind of thing. What we're interested in this particular research project is whether it's actually reasonable at all to think about rating scales and discrete choice as two different ways of getting at the same underlying representation, the same underlying utility or preference state. Is it fair to say that the two ways can access the same internal representation? So our approach is to investigate this with a tightly controlled experiment where we run almost identical discrete choice experiments and rating scale experiments using the same stimuli and very similar procedures on the same people, and then we examine whether a model of those allows us to assume identical, shared, or separate representations in the two halves of the task. Here's the very simple experiment that we used. These are 5 patches which differ in the saturation of black versus white pixels. The one on the right is the darkest patch, and the one on the left is the lightest patch. And versions of these 5, but different in the particular pixel placements, we used throughout the experiment. We created the discrete choice experiment by, on each trial, forming a choice set, choosing 3 of these 5 at random without replacement, and just asking the participant which one of these is the darkest, has the greatest proportion of black versus white pixels. That's equivalent to saying, which of the nuclear power plant projects do you like? It's the same sort of thing, except instead of having a multi-attribute decision set up like the nuclear power plant, distance, emissions, cost, this has a single attribute, saturation. The rating scale version was almost the same. We used exactly the same stimulus setup. So again, 3 pixel patches chosen at random without replacement from the 5. And instead of asking which one was the darkest, as in the discrete choice half, we queued one. That's the big upwards pointing arrow here. We're Q1, in this case, the left-hand one, but it was random, which was queued. And we asked participants, how confident are you that that is the darkest of the 3? And then they responded with a Likert scale like this one from 1 to 7, where if they chose over this side, that would indicate that they are very confident it is not the darkest one, and over this side, it's very confident that it is the darkest. Using this setup, we have two central research questions. One is about whether the data allow for a model that has the same underlying stimulus representation, the same preference states or utility, or however you want to think about it. Whether a model that has that for the DCE and the rating scale can adequately describe the data, or do you have to allow them to be separate? The second research question is, if you could only just choose one of the two methods, discrete choice or rating scale, which should you choose? And that's a practical question because that's the one that faces people when an end user approaches and says, I'd like to measure preferences about Newcastle transport. What should you do? Should you use the discrete choice experiment to ask people what they feel about the bus routes, or should you use rating scales? Here's some very basic descriptive results. I think I included these mainly to reassure you that we did actually collect data. There's not much to learn from these except that the accuracy, so the reliability with which people choose the darkest patch, increases as the patch gets darker, just like you'd hope, and is almost the same for discrete choice and rating scale experiments. That's the left-hand panel. The right-hand panel shows that there's a fairly clear response time advantage for the discrete choice task compared to the Likert scale task, the rating scale task. It would be tempting to read into this that the discrete choice was easier for people, but I don't think that's the whole story, because there's also some motor movement time advantage in the discrete choice experiment because there's the responses are easy to indicate. So that needs a little bit more discussion before we can really infer much from it. The interesting thing we did, though, was to run a model. And the model that we used was a simple random utilities model. And a random utilities model in this case works by assigning for each of those 5 different pixel saturation patches an underlying random distribution, which shows how saturated a person believes or perceives that patch to be. So this is their internal representation, analogous to their internal preference state. Then on each trial, when we show 3 of those patches, what we end up with are the 3 distributions of random internal representations corresponding to those 5. These down here are meant to indicate the 3 that correspond to any particular trial, and they have different means for the different internal representations and different variances, and those depend on which of the 5 are shown. The central research question is whether those means and variances have to differ between the rating scale and discrete choice halves of the experiment. Here's how it might look on one particular trial. There's a choice set of 3 randomly chosen pixel patches up the top. Those 3 give rise to, are represented by 3 internal distributions, the 3 normal distributions here. And then on any particular trial, you get a sample, 1 sample from each of those 3. Those 3 random samples can be used to answer the questions that the participants have to answer, because those 3 random samples represent the, on this trial, for this participant, for these pixel patches, representation of how saturated are they. In the DCE half of the experiment, it's really easy. If you have 3 samples, the question is which one is the most saturated, and so you just pick the max. In the rating scale half of the experiment, the question was a little bit harder. The question said, of the 3, one of them is queued. How confident are you that one is the most saturated? And so the way that's answered, excuse me, the way that's answered from the samples is to compare the sample for the queued stimulus patch against the maximum of the samples for the other 2. That's mapped onto a 7-point rating scale in the usual way for rating scale experiments with 6 cut points. The model can answer the questions we posed earlier using the parameters that are estimated by a Bayesian inference approach. We can ask whether the distributions that represent the stimuli are the same for the DCE blocks and the rating scale blocks. We can ask whether a model can adequately describe the data even if you force it to use the same underlying internal representations. And then we can ask, if you had to choose just one or the other, which one would give you better sensitivity? Which one would give you better or more accurate measurement of the internal representations? I've got 2 graphs here, this one and the next one, which are about model adequacy. They're meant to just indicate to you that the model adequately describes the data, and so is a useful tool for reasoning about the data. They're kind of complicated and I don't have heaps of time, so I'm going to just leave these and you can ask me about them during the Q&A if you really want. The takeaway message here is that the little crosses are the people's data, each individual person in many different conditions. and the blue dots and error bars behind are posterior predictive data. The model is adequate to the extent that the posterior predictive data cover the little crosses of observed data. In general, the model is adequate. This model is the one with separate representations. So this is the model where it assumes that you don't have to have the same representation underlying your discrete choice responses as you do underlying your rating scale choices. This is the model where it was forced to use a shared representation. The same distributions underlie data in the two different conditions, and the model is a little less adequate in describing the data. It has to be because it's more tightly constrained, fewer free parameters, less flexibility, but it still does a good job in describing the data. There's a few cases where it misses, like that one, but there's not many. The more formal way to assess that last intuition is to compare the two models using some model selection method. We used bridge sampling to estimate the marginal likelihood for each model for each person, and then calculated Bayes factors. The dots on this graph, each dot is a Bayes factor for one person. The Bayes factor compares the evidence in favor of the shared model, so the same representation underlying the two halves of the experiment, versus the separate model, different representations for the two halves of the experiment. I've drawn the graph so that the upwards direction indicates evidence in favor of the shared model, and the downwards direction indicates evidence in favor of the separate model. You can see that for the majority of people, there is evidence in favor of a shared model. There are a few people, though, these ones especially, who have strong evidence in favor of a separate model. The ratio of people favoring the shared versus the separate model is somewhere between 2 and 3 to 1. The last question we were going to ask of the model is, if you had to pick just one of the two ways of getting at the preferences of people, so just DCE or just rating scale, which would be better? That's a very broad question, and I don't want to pretend that we have the whole answer here. But one way to think about what's better is which one gets you greater sensitivity, greater separation of the underlying preference states. So which one would better separate the utilities, the underlying distributions for the 5 pixel patches? What I'm showing on this graph is a distribution over posterior samples for the difference in the separation between those underlying distributions, between the discrete and the rating scale halves. So positive values on this graph, up this way, indicate that there's greater separation between the underlying distributions when you use a discrete choice experiment than when you use a rating scale experiment. And you can see that in the posterior distribution, all of the values are positive. This is strong evidence that for all of the posterior distribution, there is better separation, better elicitation of underlying preference states, if you like, for the DCE than for the rating scale. So the conclusions from all of this are that first, we found evidence that most, but not all, people can be described well with a shared representation for the DCE and the rating scale halves of the experiment. That's good news for those of us who assume that there are 2 different ways to get at underlying preferences, and we could use either. Secondly, we found evidence that the DCE provides a statistically more efficient, if you like, way of eliciting those preferences, of measuring those preferences. Third and fourth is about extra investigations. I think thirdly, we should do more investigation of the individual differences. Why were some people indicated as having separate representations? You know, this could be a very boring reason, like those people just gave up on the experiment halfway through and therefore used a different sort of approach in the second half to the first half. Or they could be interesting. Maybe some people really do think differently about the way they do the task in the 2 halves of the experiment. The other generalization question is how this finding generalizes to more usual applications of discrete choices in multi-attribute examples like the nuclear power plants or the health decisions or transport economics that I described earlier. That's it, and thank you for listening, even though it's a pre-recorded talk. But most of all, thank you to Tony Marley for being a friend and mentor to me, and more broadly for launching this program of research, which has become a real strength at the University of Newcastle. All those times he visited us here in Newcastle and we hung out and he taught our students. He was very generous with his time and generous with his help, and we will be forever grateful for that.